Hello, everybody. So this is the extension of looking at habitat selection. And how we left looking at habitat selection is we thought about these distinct choices that organisms have to make between predation or competition or potentially mutualism. But that's not the way organisms work. Right? So when we look at this interaction filter, what we're looking at, again, is this idea that does a habitat have the necessary biotas to support or not interfere with it? And that's thinking at competition, predation, mutualism, basically any type of interaction you can have between organisms. The thing is, you need to balance these. An organism needs to balance them. Right? And there's trade-offs between making these decisions. So let's assume that the animal has the ability to make an informed decision about whether it should be or inhabit an area or not. So if it has that choice, there's simultaneous risks and benefits, and organisms basically need to integrate everything that they see around them to decide whether they want to stay there or not, or find a new place. And what we see is organisms are sometimes really good at this and sometimes really bad. They have varying sensitivities for this. Food availability is a big thing, but sometimes, they don't see that there's this other thing, maybe a predator or something that can have a really big impact on their populations, and they probably shouldn't be there. So there's a lot of differences and unique aspects to every single habitat that we're looking at. An example of this is something like risk-sensitive foraging. Okay, so imagine that you are a tiny little fish that likes to eat these red worms. I've used this example in other classes, but I think it fits really well here. Where are you going to be? Let's say we drop you off as a little fish in that refuge. Where do you go? Do you go to the left, or do you go to the right? And this is a study that was done in ecology, where they basically had a big aquarium, and they put a fence in the middle where these big nasty predators couldn't get in. Right? I think they were like largemouth bass or something. It doesn't really matter. But pretty much everyone should decide to go to the left, right? Because if you're the only fish in this scenario, or if you're the only prey fish in this scenario, you go over there to the left, right? Now, there you could say, well, what if there's like all my friends over there and I'm not going to get any food? Well, that's a different scenario. Let's just say that there's a real low density of these worm eaters. You're going to want to go to the left, right? What happens if there is now, you double the worm density on the right, where you have 0.33 worms per centimeter squared. And what we see is the fish still stay to the left. But when these experimenters put their the worm density up to 0.5 worms per centimeter squared, they found that most of the worm-eating fish went to the right here. They came over to the side of there's a lot more food. Now you might ask, well, why is that fish doing that, right? Why is that fish making that choice? Well, what it's doing is it's integrating these two habitat like interaction filtering mechanisms, right? So it knows, yes, it's safer over here, but there's so much tasty food over here. And what we see is probably from a population level, this almost 3 times the amount of food over here probably increases total population growth, that the population itself can probably grow faster in this type of scenario. Even though there is like heightened predation, there's probably enough food to support these little fishies and keep their population going. And we found that they found the same with the 1 worm per square centimeter. So these type of risk-sensitive foraging things are an example where organisms have to integrate all of these different factors: food availability, predation risk, how many other, of these little blue fishies are around them. We'll talk a little bit about the landscape of fear when we come back, and for our in-person meeting, and we'll spend some time thinking about this in a how organisms are choosing where to be on relatively small spatial scales with human impact. All right, with that, I'll see you later.